In this video, we are going to cover two different strategies for multiplying polynomials. Now, as we work through a few examples, please recall your exponent rules because they're going to be critical to ensure we end up at the correct simplified expressions throughout this video and beyond. Now, we're going to approach this problem by using a geometric diagram. Now, a geometric diagram is a great organizational tool. As polynomials get more complex and contain more and more terms, a geometric model can really assist you in making sure you keep all your terms nice, neat, and organized. Now, to set up this diagram correctly, we need to analyze the number of terms in each of the polynomials. In the first polynomial, there are 3 total terms. This makes the first expression a trinomial. To account for all 3 of these terms, we will make sure our diagram is 3 cells wide, writing each term above each individual cell, as you see here happening on your screen. Our second polynomial, which can be more accurately called a binomial, because it has 2 terms, now we can make it 2 terms vertically, or 2 terms tall, 2 cells tall. So ultimately, we have a diagram that is 3 by 2 with 5 total cells here. Once again, down the left-hand side here, we are writing each individual term next to our cells. Once we are set up and organized, we can start multiplying. Now, each of the blank cells are filled by multiplying 2 of the terms on the outside of the diagram. For example, 3x squared times 2x will fill this cell. Since 3x squared times 2x results in a product of 6x cubed, we can fill this cell with 6x cubed. This process continues until we fill every single cell. 3x squared times 3 equals 9x squared. Since we have finished the first column, we're going to move over to the next column. By the way, you can multiply these terms in any order. You just need to make sure every single cell ends up being filled out. 4x times 2x equals 8x squared. 4x times 3 equals 12x. 2 times 2x equals 4x. 2 times 3 equals 6. Now we have filled out all 6 of our cells in our geometric diagram. And now, since it is complete, the next thing we need to do is see if any like terms are present. Remember, like terms contain the same variables and the same exponents on the variables. Terms are also like if they are constants. I notice we can combine 8x squared and 9x squared, which results in 17x squared. 4x and 12x can also combine together to make 16x. Now, 6x cubed and the constant of 6 have no like terms, so they're not going to be combined with anything. When I'm writing out my answer using this geometric model strategy, I like writing out each individual term actually first in a straight line like this, and then ensuring while I'm doing that to put the like terms next to each other. This allows me to stay organized, but more importantly, it also guarantees that I do not miss any of the terms I need. I also write the expression out with the thought of getting my final answer in standard form. That means the greatest degree term, which remember means it has the greatest exponent, coming first and then going in descending order from there. When I rewrite my expression, I have these 6 terms. As mentioned previously, I can combine like terms here and here. This leaves me with a final answer of 6x cubed plus 17x squared plus 16x plus 6. This is written in standard form, and it is a 4-term cubic polynomial. Now, let's take a look at the problem we literally just did in a different way. We already know the answer, so as always, I want you guys to really this time focus on the process, not the final result. We already know the final result. So we are already familiar with something called a distributive property, right? If this problem was simply written like this, which eliminates the 3, you would simply distribute that 2x to every term inside the parentheses, right? Well, the same thing is true when you change the monomial, which is the 2x, to a binomial, making it 2x plus 3. The only difference is you need to distribute that 2x, like you're used to doing, to every single term. But then you go back and also distribute the 3 to every single term. So let me show you what this looks like. First, I'm going to distribute the 2x. When I distribute the 2x each term, as you see on the chalkboard, I end up with 6x cubed plus 8x squared plus 4x. Now I need to distribute the positive 3 to all terms inside the parentheses as well. So that's where it gets a little bit like next level from what maybe you're used to. This leaves me with 9x squared plus 12x plus 6. Similar to before, I can then combine like terms, making sure to write my final answer in standard form. Notice I end up with the exact same answer, obviously, because it's the exact same problem, but it does not matter which strategy we use. Whether you want to utilize a geometric diagram or simply write it out with distribution over and over again, as long as you utilize the strategy correctly, you're going to end up with the same right answer and you're going to be good, you're going to be set to go. Now, I want you to take a second to try this next one. Use whatever strategy you want, but make sure you are organized as you work towards your answer. I'll check back with you in a second so you can check your work. This problem represented a trinomial times a trinomial. Even though we have one more total term here than we did in the first example, it doesn't change the process. If you decided on a geometric model, you should have created a 3x3 square grid because you have 3 terms times 3 more terms. Now, it doesn't matter which expression you wrote across the top and which one you decide to write vertically. It's really irrelevant, so just keep that in mind as we go through. Your grid may look a little different, once again, depending on how you set things up, but you should end up with these 9 terms in your grid. Now, if you decide to use the distributive property, you're going to end up with the same 9 terms. So do a quick check whether you did the grid or the distributive property, and make sure you have all the terms, the 9 different terms, correct. Because if you didn't get the 9 terms correct, you're not going to be able to simplify correct. Now, from here, all we are working to do at this point is combine our like terms. That is why, once again, I noted if you don't have the 9 terms correctly, you're not going to be able to simplify correctly. Even though there are a lot of terms here, right, there's 9, the only terms that are like are negative 2x squared and 3x squared. Also, x and 2x are like terms. So there's only 2 pairs of like terms. Negative 2x squared when combined with 3x squared results in just x squared, and x and 2x combine to make 3x. So we have finished combining all of the like terms here, but we must make sure we write our answer in standard form. It means putting the highest degree, highest exponent term first. And once we do that, this is our final answer. So in this video, we have gone through how to multiply polynomials in 2 different ways, using a geometric diagram and simply using the distributive property. I would recommend that those of you who struggle a little bit with organization, stick to that geometric diagram. It puts everything nice and neat in this table form. The geometric diagram is also great if you have a bunch of terms and you really want to keep that organization in order. With that said, do whatever strategy works best for you, and the best way you're going to understand this is to continue to practice, practice, and practice some more.